5-3. We are learning our next set of identities. Okay?
Yeah.
These are the sum or difference identities. And what they do is they help us. For instance, example 1 says find the exact value of cosine of 15 degrees. Is 15 degrees one that's on our chart? No. Is that one we know? No. So if they want an exact value, that's not the decimal equivalency. It's not using the calculator. And so this is where these sum and difference identities come into play. Because what we're going to do when it comes time to looking at cosine 15 degrees is we're going to look for numbers that we do know information about that will give me 15. Okay? So 3 that we're going to add on to our list of what we know here. The sign of a sum or difference. So notice here it says sine of x plus or minus y. As in, this could work 2 ways. If it's sine of x plus y, so 2 values being added, then it's going to be sine of x cosine of y plus cosine of x sine of y. Or it's the bottom sign, the minus, sine of x minus y, then over here you're going to use the bottom sign minus as well. So sine x cosine y minus cosine x sine y. Cosine is a similar situation. Cosine of x plus or minus. Difference is pieces are switched around here, right? You got cosine, cosine, cosine x, cosine y, and then sine x, sine y. Notice this sign, though, is a minus plus, if such thing exists. But the idea on the first one, both pluses are on top, both minuses were on top, so they correlated. Here, this is saying if it's cosine of x plus y, we're going to use the minus there. If it's cosine of x minus y, we're going to use the plus. Okay? Sure. Yeah, I mean it's just the formula tells us instead plus or minus we're going to use minus plus. Okay? I'll demonstrate, okay? So yeah, reverse it. Then we have tangent. Okay? Tangent is our fraction one. Again, once you know tangent of x plus or minus y, we'll set it up. Notice on top there's plus or minus, on bottom there's minus plus. Okay? So those are the formulas we're going to practice using. So let's look at example 1.
Okay.
Find the exact value of cosine of 15 degrees without using a calculator. So do notice it says exact. An exact value is like in terms of numbers from our trig reference chart. Okay, so square root of something. In other words, if the answer is square root of 2, I want you to tell me square root of 2, not 1.414. Okay? So, we already decided 15 is not on that chart. Do you know a couple of numbers from our chart that could give us 15? And since these are sign and sum or difference, 2 numbers that could add or subtract to be 15?
45.
Could we use 45 and 30? 45 degrees minus 30 degrees is 15 degrees. So one option here is that we can rewrite this as cosine of 45 degrees minus 30 degrees. Is that still equivalent?
Yeah.
And I guess I can put over here. What are we starting with? We're starting with cosine of 15 degrees. Well, I've just rewritten it. 45 minus 30 is 15, yes? We picked 45 and 30 because I know some stuff about 45 and 30, don't I? Those are on my chart. So now, we're going to set up our formula. And when we set up our formula, think in terms of 45 degrees is in the position of x. 30 degrees is in the position of y. So every place we see an x, we're going to replace it with 45. Every place we see a y, we're going to replace it with 30. So let's write it out. Cosine of x plus or minus y is cosine x cosine y. So that's going to be cosine of 45 degrees times cosine of 30 degrees. Now, since this was cosine and my initial sign is a minus, Now my middle sign is going to be a plus, because cosine, the identity tells me to switch the sign. And now, so it's going to be plus sine x, sine y. So sine of 45 degrees times sine of 30 degrees. And now, we plug this in, or we don't plug this into our calculator. We get the values from our chart, yes?
Yes.
Do we know the cosine of 45 degrees? Let me rephrase that. What is the cosine of 45 degrees? Square root of 2 over 2. Straight off the chart. Cosine of 30. What is the cosine of 30 degrees?
Square root of 3 over 2.
Square root of 3 over 2, yes? Not magic. Coming right over there off the sideboard.
I think
Plus sine of 45 degrees.
Square root of 2 over 2.
Times sine of 30 degrees.
1/2.
1/2. Okay. All we're going to do now is we're going to clean this up. Okay? And I'm going to express it how you often see these answers expressed. First of all, fraction times fraction. Square root of 2 over 2 times square root of 3 over 2 is?
Square root of 6 over 2.
Square root of 6 over 4. Because square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. It's not a common denominator when multiplying. What about square root of 2 over 2 times 1/2?
Square root of 2 over
4.
Do you not know how to multiply?
Square root of 2 over 4. Now, most often, how you'll see the answers expressed is put it together as one fraction, because we already have a common denominator here, yes? So if I put this together as one fraction, I'm going to say square root of 6 plus square root of 2 all over 4. And we can't add because they are not like radicals, correct? Right. In order to add, they have to have the same number underneath the radical. Now, real quick, I want to just kind of demonstrate the proof that this works. And I know a lot of you guys are saying, yeah, I don't really need proof. It just works. Okay, whatever. But
The math is math. Math is math. I'm literally did.
okay, real quick.
Jesus Christ. This is
Ooh.
Jesus.
Okay, if I enter square root of 6 plus square root of 2 all over 4, it is equivalent to this decimal, yes?
See.
Now, if I do, hold on here, cosine of 15. Notice,
The same thing.
it's the same thing. Okay, the catch is we can't just put it in on the calculator because we need a way to get an exact value. And an exact value is the one with the fractions and the radicals. Okay? So there's your proof that it works. Is that something you can do to check yourself if you ever feel the need?
That's what I was just getting ready to say.
Sure can. Okay? I mean, I'm going to show you. You can check yourself all you want. Is it going to help you find the right answer? Not really. So, okay, questions there. I will say, we're not doing a ton of examples like this right now, but this is one of the big things you're going to be doing in homework. Okay? Now, you guys told me 45 and 30, so we used 45 degrees minus 30 degrees. Was that the only option? No, what else could I have done?
60 or 45.
Yeah, could I have done 60 minus 45? Does it work?
You can do anything that
Okay.
subtracts 15.
Well, two numbers that subtract to be 15, but they have to be numbers we know the information about, yes?
Yeah.
Okay, so if we don't know information about them, it's not going to work. So your focus is 30 degrees, 45 degrees, and 60 degrees. Okay, example 2. Write each of the following expressions as the sine or cosine of an angle. So here we're working our identities backwards. We're not doing anything fancy. We're just working our identities backwards. So we want to know, is this equal to sine of some angle? Or is this equal to cosine of some angle? Or technically you could say tangent of some angle, because we have those 3 identities. So first of all,
Sine of some angle.
why sine of some angle?
Because you could look at the way the cosine and the sine
Okay.
match.
Does this fit the sine identity up above?
Yeah.
Because the sine identity up above says sine of x, cosine of y, and then cosine of x, sine of y, yes? So, for that reason, I know that this is going to be the sine of some angle. What angle?
If it's plus, it has to be plus. You have to do 22
I was
plus
thinking
13, which is
35 too.
34.
Okay. And keep in mind, the idea here is 22 is in the position of x. 13 is in the position of y. Is that consistent here? X, y. So my x and y values we're using are the 22 degrees and the 13 degrees. And then as Kylie says, the sine one, the signs match. That sounded really confusing.
Decide on the size.
The sine trig function, the plus or minus signs match. Okay? And so since this is plus, then we're going to use plus here. Don't stop here. Be smart. What is 22 plus 13?
35.
And there is the sine
5.
of 35 degrees. Okay? Technically, if you typed in this expression on your calculator, and then you typed in sine of 35 degrees on your calculator, they would both come out the same, yes? Okay, let's try B.
35.
What about B? What can you tell me? Cosine? Why cosine?
Because the identities match.
Okay, this is cosine, cosine, sine, sine. So here I'm going to be looking at cosine. What are my x and y values?
Can you switch them to like the equals?
That's radius.
Okay, guys. You have to learn to work in radians. So no, we're not switching to degrees. We are working in radians. AKA, you have to learn to work with fractions, because that's all radians are, is fractions. Okay? So, sorry, I'm going to be mean about it.
Shut up. Maybe I will.
Okay,
Maybe I will.
so this is cosine. My x and y are what values? Pi over 3, pi over 4. Am I adding or subtracting those?
Subtract.
I am subtracting because this is the cosine identity, and that was the one that changed from plus minus to minus plus. So you use the opposite sign. Okay, guys, don't stop here. Subtract those. How do we do pi over 3 minus pi over 4?
By the common denominator.
It's fractions, guys. Common denominator.
Wow. That's what I got.
So common denominator of 12. 3 times what is 12?
4.
4. So 4 times pi is
4 pi.
4 pi. 4 times what is 12?
3.
3. So 3 times pi is 3 pi. What's 4 pi over 12 minus pi over 12?
Pi over 12.
So this answer is cosine of pi over 12.
I like this chapter.
Okay? Don't be scared of the fractions. Work them.
I'm not scared.
Okay. C. Sine x, sine 2x minus cosine x, cosine 2x.
Why did the exit? That was so good. But it is.
It's cosine. Yeah.
It's cosine.
It's cosine, but
It's flipped.
it's flipped, yes?
Yeah.
Now, okay, for that reason, I'm going to flip it before we actually clean this up here because there is a small trick to this. Okay, no, it's cosine, I agree. And we know it's cosine because there's a sine and a cosine, right?
Yeah.
And that matches the cosine identity. The thing is, with the cosine identity, it starts with cosine. Wouldn't be a big deal if this was a plus sign. It's a slight deal because there's a minus sign that we're going to have to adjust. Okay? So I'm going to flip this around, and I'm going to rewrite this as negative cosine x cosine 2x plus sine x sine 2x. Because I need you guys to see the visual here of it still kind of looks like cosine, but does cosine ever begin with a negative? No. So my suggestion here is that we factor out a negative. So I'm going to take, so it's like factoring out -1. I'm going to factor out a negative. And if I factor out a negative, what's this going to read now?
Cosine x, cosine 2x.
Plus sine x. Minus.
Sine x. Or sine 2x.
Okay. So now, by factoring out the negative, two things happen. One, it just tells me when we get to our final answer, it's going to have a negative sign in front of it. And two, now what's in my parentheses, does that match my cosine identity better? It does. Okay? So, keeping my negative out front, we already decided that this is cosine, yes? Cosine of what? What are my x and y values? No?
X and 2x.
X and 2x. In other words, when I ask what are my x and y values, what are in the variable positions? And in the variable positions, I know it's weird, but it is x and 2x. Final trick question. Am I adding or subtracting x and 2x?
Adding. Actually, I don't think that's right. No, you're adding. You're adding. This is how you know it. Because then you would multiply it. Yeah.
The way this finally worked out, this is cosine minus sine. It's a cosine identity opposite of the middle sign, so it is adding. So this works out to be negative cosine of 3x.
That's right.
It's a little trick there.
Didn't you have to have the parentheses right there?
I would say yes, you should have the parentheses around 3x because we don't want it to be read as cosine of 3 and then times the x. And so this is definitely indicating that it's cosine of 3x. So I would encourage the parentheses there. Okay? Next one. What do we know?
Tangent.
Is it fairly obvious it's tangent?
Yeah.
If it's the form, yes. Okay, so I know here, I'm going to say tangent.
Your x.
What are my x and y value?
And y is
It's the 22, whoops, and the 23. 22 degrees, 23 degrees. He says add. Do we agree?
In total, you should get 45.
Okay. Adding because on top of the tangent identity is plus or minus, just like in the middle of the tangent identity is plus or minus. So we do the same as the top sign. The bottom of the fraction says minus or plus if you look at it. So it's the opposite of that sign. So it is plus, and 22 plus 23,
45.
I was told it is tangent of 45 degrees.
This is so easy.
Okay. Well, and here's what I'm going to say, guys. The homework is more like number 1. There's going to be a few tricks in the homework that I'll have to share with you. Okay, but the identity itself is pretty easy to use. It really is.
Sophie's going to be matching this.
Okay, we ready for example 3? Example 3 asks us to simplify each of the following. And it says the sine of x plus pi. Now, as it is right now, it doesn't appear that we can get that any simpler. However, here's the deal. Sine of x, we're not going to know what to do with sine of x. Could we maybe know what to do with sine of pi if we think about it? It's a number, right? Okay, so, excuse me, write this out with your sign identity. So this is sine of a sum, yes? How do I write this out based on the identity at the top of the paper? It's already sine of x plus pi. How do we rewrite it out with our identity?
Oh, sine x times cosine
Y.
y.
Okay, so with the idea that every time you see an x, we're going to put an x, yes? Every time we see a y, what am I going to replace it with? Pi. My sign identity starts sine x cosine y. So this is going to be sine x cosine of pi. Plus or minus. This is a sign identity, so we keep the positive negative sign the same. And now it's going to be cosine of x times sine of y, which is pi. So you're writing out the expression sine x cosine pi plus cosine x sine pi. Now, the directions were to simplify. Do anything you can to clean this answer up. Do we know the sign of x? No, because x is a variable. So sine x is going to stay sine x. Do we know the cosine of pi?
Negative.
Why?
Because my unit circle says so. Because it's a transverse angle. Isn't that what it's called? Quadrant.
So the chart you're going to need to think about down here, or not chart, but remember our quadrants, our quadrantal angles. Think about these ordered pairs, yes? So when it's asking for cosine of pi, where is pi? Right over there. And remember, in an ordered pair, it is cosine sine, yes? So cosine of pi is going to be -1. Plus cosine of x is cosine x. Sine of pi,
0.
according to our quadrantal angle there, 0. Well, clean this up. What do we get?
Negative sine of x. Negative sine.
Negative sine of x. Sine of x times -1 is just negative sine x. What's cosine of x times 0?
0.
It's 0. So this just cleans up to be
Should we put parentheses around that x?
negative sine of x. I would say you don't have to put parentheses around this x because it's just one term, one piece. Okay, let's try B. Cosine of x plus 3 pi over 2. Write out the identity with me, please. What do we start with? Okay, this is our cosine identity, so it starts off cosine, cosine, cosine x, cosine 3 pi over 2, plus or minus? Opposite sign for cosine, and now the second part of this is sine x, sine 3 pi over 2. Okay, clean it up. Cosine of x is cosine of x. Cosine of 3 pi over 2. If I go back and use my picture from earlier, right? Cosine of 3 pi over 2 is right there.
0.
I do agree with the 0. Minus. Sine of x is sine of x. Sine of 3 pi over 2. Negative 1. Cosine of x times 0 is going to be
0.
0. It's gone. What remains?
Sine x.
It's forth making it possible.
Negative sine x times negative 1, which will become positive sine x. Okay. One last one on this page.
Pi over 4.
Now, that is a pi over 4. Okay, so understand that that is a pi over 4. This time, we're doing a tangent. So, what goes on top? Tangent of theta minus tangent of pi over 4. So we keep that sign the same on top. What about the bottom? Okay. The bottom always starts off with 1. And then in this case, it's going to be plus because it's going to be opposite the sign you started with. And then tangent theta, tangent pi over 4. Okay, clean up. Tangent theta is tangent theta. What's tangent of pi over 4?
1.
1, according to my chart. I like math when it's easy. 1, my denominator, 1 plus tangent of theta is still tangent of theta times what's tangent of pi over 4?
1.
1. What do we end up with here?
Tangent of theta minus 1 over 1 plus tangent.
Okay. Tangent of theta minus 1 over 1 plus tangent theta. Now, the homework that goes with this is page 418, 1 through 22. Got through that super quick. We actually have some work time.
Great.
To save issues later, can I show you one more? It's actually going to be a problem from the homework.
What number?
I wouldn't be mad about that.
Well, I have number 6 written in my notes. It's a good, tricky one, so to speak. Now, what I'm going to tell you is you could put it on the back side of your notes right now if you want, and then copy it in later. I have to find a page where I want to put this. I'm going to put it right here. Now, and here's why I want to look at number 6. If it's the problem I think it is. Is it sine of 7 pi over 12?
Yeah.
Because here's the deal, guys. Our very first problem with the notes was cosine of 15 degrees. When I asked you, give me 2 numbers from my chart that add or subtract to be 15, that was piece of cake, wasn't it?
Yeah.
Okay. Give me 2 numbers from my chart that add or subtract to be 7 pi over 12.
See, now that's valid.
Well, that's a problem.
That's a little trickier, isn't it?
Wait, no, it's
It's
pi
there, I promise.
pi over 3 and pi over 4. There's 5 pi. There's what?
Okay, so here's what I'm looking for. Is I'm looking for sine of 2 numbers, and I'll tell you it's add in this time, but it could be add or subtract, that add to be 7 pi over 12. The problem is, when we look at our chart, my choices are pi over 6, pi over 4, and pi over 3.
Common denominator.
So,
Right?
no, we have to think common denominator. So here's what I'm going to suggest you do. make a chart on your notes. That includes pi over 3, pi over 4, and pi over 6. Write down a list. What are these when they have a 12 in the denominator? Pi over 3 is how many twelfths?
4.
4 pi over 12. Pi over 4 is how many twelfths? 3 pi over 12. You multiply by 3. Pi over 6 is 2 pi over 12. Now, is this chart only good for this problem?
No.
No, you'll see a lot of twelfths in homework, which is why I felt like I needed to add one more problem to the notes, but it's also a problem from homework. Okay? So, now what two numbers would you like to use?
Pi over 3 and pi over 2.
Okay, now, for the moment, I'm going to write it as 4 pi over 12 plus 3 pi over 12. Only because I don't want the, huh? What? How did you know that? This is how I know it. Does that make sense? Okay, now, if I continue on through here, the idea is the next step, I'm going to reduce these. Oh, hey, 4 pi over 12 is pi over 3, plus 3 pi over 12 is pi over 4. And now I'm like, oh, I can do this because those are in my chart. Now, if we run through this problem right now just because we can, what's our sign identity look like? Sine of pi over 3 times, what do you say? Cosine of pi over 4. Because which identity are we using here? The sign identity. The sign identity goes sine, cosine, and then plus. And now it's going to be cosine pi over 3 sine of pi over 4. And now we can do this problem just like we did cosine of 15 degrees, yes? What is sine of pi over 3 according to my handy dandy chart?
3.
What is cosine of pi over 4? Square root of 2 over 2. Plus, what's cosine of pi over 3? 1/2 times what's sine of pi over 4?
Square root of 2 over 2.
Okay, can we clean this up? When you do your multiplying, square root of 6 over 4 plus square root of 2 over 4, which I'm going to continue one more step and say square root of 2 plus square root of 6 all over 4.
So it's just like the same answer we got.
Well, here's what I'm going to tell you. A lot of your answers in these problems are going to be variations of this. Switch the numbers, switch the signs. You're going to have a lot of variations of this. So there's one free homework problem done with some tips of how to do some others. Got it?